All right, so remember that benzene has delocalized electrons in that pi bond that gives it a high amount of stability. We draw the circle instead of in 3 individual double bonds because of the resonance and the physical evidence that the carbon-to-carbon bonds are all the same length. So that's why we want to draw it with that circle. Now, what's going to happen is benzene is going to be able to undergo substitution reactions. So we're subbing out a hydrogen and whatever we're bonding or reacting it with. So in this case is bromine. And so instead of having a hydrogen here, we're swapping out one of the bromines for one of the hydrogens. And so we get bromobenzene and then HBr as a product. They can also undergo substitution with deficient reactants. A common example is nitric acid, and so in fact we end up with NO2 being electron deficient because of the positive charge, and that can bond to the benzene. So an example of a question might be benzene reacting with chlorine, and so if we draw it out, we have benzene. Remember that there is also a hydrogen coming off of all of these carbons so that they have their 4 bonds, and then you're reacting it with chlorine. And so one of the hydrogens is going to break. This bond between the 2 chlorines is going to break. The hydrogen will go with 1 chlorine and the other one will replace. So we end up with chlorobenzene and HCl.